Creating a data file for analysis involves at least a couple of steps and might seem a little overwhelming, but if we take it step by step, it isn't too bad. The process can be summarized in two broad steps: preparing raw data and computing scores. Preparing the raw data includes creating a file, naming variables, formatting data, and checking for invalid data. In some cases, we need to enter the data from paper-based surveys or records. If we administer a survey electronically, we won't have to enter data, but we will have to go through a process similar to what we do with paper records. This video will focus on that process. In learning about data files and statistical analysis, we'll use a process similar to what we've done with other topics. I'll walk you through all of the steps for an example based on one survey. You'll practice with information from a different survey and check your work. Then you'll complete the process a third time on your own. If you haven't already looked at the guides, you might do that after you watch this video. They'll help refresh your memory as you practice and work on your own. This is a good time to note, too, that the data we will use for the example and activities is only for the purpose of learning about these processes. It's not legitimate research data. Now, on to the featured attraction. As I mentioned earlier, if we have data on paper, we need to enter that data. In those cases, we can create our data file in Excel and save a step later. I'll include resources about that in the class materials. Sometimes it's more practical to start in Excel, though. For example, if we use a Google form to administer a survey, we can download the data into Excel. We just open the file in the Google Drive, go to the File menu, select Download As, and select Excel. It'll open the full data file in Excel. It'll look like the worksheet in this slide. You might have already noticed that the file looks a little overwhelming and doesn't seem like something we can analyze with statistics. It's a good call, and part of the reason we need to work with it. We will eventually move the data into SPSS to conduct analysis, so we'll need to keep some things in mind to make our lives easier at that point. SPSS calls each of the questions in the dataset a variable, and the responses to each question are called data. The Google form identifies each question, or each variable, by putting the full question in the first row of the column and the data in the following rows. SPSS won't be able to work with having the full question in the first row. SPSS doesn't work with spaces, among other things. Having that much information also makes it complicated for us, so the first thing we'll do is change the first row. The easiest way to identify the variable is to include an abbreviation for the name of the measure and the question and the question number, without any spaces. In the example on the slide, you can see I started by changing the top row to SGS1, SGS2, and so forth. I did that because this example uses the short grit scale, so for other data sets, you would use the abbreviation that makes sense for the surveys in that data set. That said, we may also have demographic variables in the data set that will need to have new labels for SPSS as well. When we work with statistics, we usually treat scale scores as interval data. In other words, instead of treating the responses as words putting people in categories, we assign numbers so that we can compute the mean and the standard deviations. When we have information about the response options for a survey, we usually also have the information about the numbers that are assigned to those response options. For example, when Duckworth, Peterson, Matthews, and Kelly developed the original, slightly longer version of the short grit scale I'm using in the example, they labeled the responses 1 through 5 as noted in this slide. So we'll do the same thing. In Excel, you can hold down the Control button and hit the F key to access the Find dialog. Then we select the tab that says Replace. From there, we put the wording for the response option in the top box and the number for that response option in the lower box. Then we click Replace All. If you copy and paste the response options, make sure to delete any extra spaces at the end. The search feature is sensitive enough it'll say it can't find the phrase because it doesn't have those spaces at the end. Excel will go through and change all of the fields, and you'll see a notification that it's done. We'll need to repeat that step for each of the 5 response options. Note that the Replace All function is literally just looking for the characters you tell it to find, so you want to be careful about what order you go in to replace the response options. Sometimes you need to go out of the sequence altogether. For example, if you had the scale in this slide and went in order, after you replaced all of the agrees, all of the disagree responses would end up being dis2. To avoid chaos, you'll need to go in the order they would listed on the right. Before we move on, we also want to make sure all of our data is valid. This is a good time to note that we don't need to throw out responses from a participant if he or she did not answer every question. SPSS suggests analysis is necessary, so we can use the data that is available without messing up results because of the missing data. For example, in our data file for the short grit scale, you might notice that row 16 is missing a response for question 4. That's not a problem. Remember, though, that participants may respond in a way that does not represent a valid measure. It might be all negative or all positive or all in the middle. Some scales use reverse score items to help detect that. In other words, they include a question that should have a different response than the others. In this case, we still eyeball the data and notice if there are any rows that contain the same response for every question. If there are, we'll delete the row from the data set. In our data file for the short grit scale, row 6 is an example of this. The participant answered 5 to all of the questions. In some cases, we can move on and Excel will compute what we need for analysis. Excel is limited though, and the SPSS program can actually be easier once we get used to it.